Um, Hi guys, can you hear me? How's the sound quality?
Hello, all good.
Okay, great, great. All right. Well, if you remember, today we have only one class. Well, as it was planned from the very beginning, and today we will be overlooking. Since we don't have much time, like only one class, so we'll be overlooking one interesting example of the code, how the Python can be used, and actually not only Python, but it will be, I suppose, an interesting thing. All right, so I'm going to share my screen, and we could start working. Okay, so screen is shared. I suppose you can see that. And I shared next materials. Maybe I will share even this one. So we will talk a bit about stenography, and we will be trying to make a stenography codes. Okay, I will have to save it. In such way. Then I'm gonna save a zip file and a Python file. Okay. So maybe you guys know what stenography is. Sorry, not stenography, but steganography. Maybe you already used that thing somewhere.
Honestly, I don't think so.
Okay, so I suppose you're too young for using this because this was quite popular some decades ago actually. Steganography is actually about hiding information in some data chunks. It's like hiding information into the picture, for example. Okay, and let's maybe open material. So again, I'm switching to the Windows system, and I'm gonna open the file. Well, there are a lot of possibilities to hide an information into data. One of very popular approaches is to use pictures. Pictures. Hiding information to pictures can be done in a very different manners. Maybe you have heard about such things as maybe that's called as cicada contests. Maybe
Say again, SCADA?
cicada. Okay, well, probably you didn't heard about this. I can even maybe show you. We will be able to just switch to the English version in the Wikipedia. Let me switch to the English version. Yeah. So there were pretty popular some around a decade ago. A lot of interesting kind of um, puzzles in the internet, not really understandable, from where they literally come, but there were a lot of interesting tasks related to cryptography and hiding information, taking that out from pictures and so on and so on. It was kind of fun stuff actually. I just assume that it might happen that you know about these things. But okay, if no, then no. Well, literally hiding information in pictures and just in data is pretty popular, and the thing is that we cannot really say, looking at the picture, that something is hidden inside. And as you probably have heard, we can even hide executable codes inside pictures, inside MP3 files, and so on and so on. All these things are doable, and people do that. Yeah, so the only thing, it could be an interesting how to make one, right? The thing is that all set of information which we see, which we hear and read, it's been made from a sequences of bytes. And I suppose that pretty understandable, because everything which is stored on a computer, or let's call it, mm, or maybe let's call it better, on electronic devices, is being encoded in binary codes. Well, literally, why? Why so? Why exactly binary codes? It's not only related to computers themselves, it's just related to a possibility for a machine to store the data in the aspect of states of the chords. For example, if you have one chord, it has two states. If you have two chords and you mark each with its own number or the position, then you have like a four overall states. And same happens for all the data, all the variables we're using in programming languages, and well, let's say integers, right? Integers can have, well, can be both positive, negative, or we can use only positive integers, right? But the range of such integers covers all set of negative and positive integer variation. I suppose you know that maybe from such programming languages as C++ or maybe Pascal, if you know such programming language. Yeah, so that's related to so-called electronic devices. Yeah, so literally, if something reads a data, it reads data in binaries, right? And a machine should react on those binaries somehow. That makes it possible to write viruses, or let's call it instructions that are being executed while picture is being read by operating system during opening. All this is nothing really complicated to implement, but I'm not gonna teach you how to make exactly these things. Yeah. And surely, as for the Python, there surely are a lot of possibilities to make a conversions, let's say from text to the binary codes, and in the opposite direction. From the binary codes, we can have text. For example, you can see on the screen exact operations how to do that. In the manner of two functions, text to binary and binary to text. And that thing is not really complicated. The main thing is to get that. Well, you can do that. Okay. Well, I suppose we are good with this, and this is clear. And next thing is, let's talk about maybe the colors, maybe the pictures. Well, if we would talk about, let's suppose, images, right? Um, and we would find out the way how to store data in images. We can remember that each image is just a bunch of pixels. I think you would agree with me. And in the similar time, each of these pixels um, actually is um, a set of so-called channels. I would rather call them as components. And idea of those components is that they're located very close next to another one on the screens, and they form by such very small tiny distance a combination of waves which is understood by our brain, surely when it comes to dice and then eyes, and then from eyes we have a signal to the brain, then this varieties and combinations of waves is understood as some particular color, even besides the fact we use only three different components, red, green, and blue, and their varieties give us different colors we see. Well, actually, we trick our mind with, actually. Okay, well, I suppose surely this could be pretty clear. And since those components are some light producing stuff, then it automatically means that that light has to have its own parameter. And it just historically happened that we're using RGB. Um, we're using RGB style of the pixel that assumes in most of the cases there could be very rare cases when it's different, but in most of the cases there are 256 varieties of the light of the component of the pixel. So which means that you have three components and you have literally a variety that takes a space of the 1 byte. So one pixel takes 3 bytes, and then you can calculate what is the overall size of the picture. Let's say if picture contains million pixels, like 1,000 on 1,000, right? Like the square. Then we can multiply that million with 8 and we'll find out what is the size of the picture. I suppose that makes sense, right?
Yeah, yeah.
Yeah. And let's just make a fast calculation. Even thinking like about that million of pixels. So we already know it will be 8 million of bytes. So let's find out how many kilobytes is it. We have to divide it by 1024. Who knows why exactly 1024?
Because that's 1 megabyte or 1 byte of
Let's
bits.
call it a 1,000 byte group, right? Okay, so we find out how many then kilobytes we have, and let's find then how many megabytes we have. Okay, so 7.6 megabytes per a picture, or 1,000 by 1,000. Well, such picture is not pretty huge, and this is uncompressed way of storing the data. Well, but I suppose none of us use such huge pictures, right? Mostly we use pictures which takes much less space, even in case they are quite bigger than 1,000 on 1,000 pixels. But such thing I mentioned previously is uncompressed picture, and there are different formats of pictures which literally use different methods of compressing data. It might happen we will be talking about those compression methods of pictures, but the most thing you have to know is that those formats are pretty different. And for example, if we will take the classic Windows application for pictures called Paint, we will be finding out that we can have at least such formats of the pictures. And surely we're not talking about GIF pictures. So BMP is uncompressed format, which takes the full size of the picture, but showing that and operating with that picture happens pretty fastly. So the BMP will take them is the format that takes the most biggest pictures. Then we have JPG and PNG. And the PNG is the format that compresses data stores additional information into the file, like the color palette which is used for the picture, and we can always restore from the PNG the original picture itself. Then there is a JPG format. And the JPG format actually has 5, or nowadays there is even the 6 variety. Okay, let's call 6 variations of JPG. But the thing is that JPG is the algorithm that loses the quality, so it loses the originality of the image. In the same time, it takes less memory than the PNG to have to store the picture, but in the same time, you cannot restore the original image from the JPG file. So you always see destructed a bit file. You don't see an original picture. So we will be using today exactly PNG files, because things which we can write in them directly will be still available. And if we will use a JPG picture, everything which we will try to store inside will be modified. So that's the thing which you have to know actually. But if you don't know, you can always inform me, and I can give you additional materials about this, because this subject is kind of really huge actually. Okay, about colors themselves, all is good, right?
Yeah.
Okay, cool. So what we'll be doing? So we will be pulling a text inside the picture. So here we have a really fancy picture. Well, who doesn't like cats, you know? But what can we say about this picture from the aspect of pixels and colors? Guys, what can we say about this picture?
I don't know. It's bright.
Okay, it's bright, cool. So it means that values of the pixel components, they have values over the half. So as value is higher, as pixel brighter, as they are lower, as pixel darker. Okay, so they have mostly more than the half of component values. Okay, what else we can say about this picture?
It's very detailed. Like you can see all the hairs.
Okay, what else? Maybe something about colors.
Orange.
Yeah, so it's orange, somewhere like brown, like a reddish, you know. And literally, it's a pretty compound picture, because there is probably a sunset, right? And uh, and that means that we cannot, if some of the sectors of the picture would be kind of containing incorrect colors, we wouldn't recognize that. Maybe that's the lighting issue, you know. For example, this line that comes in the corner, you see my cursor, right?
Yeah.
Most likely that could be a sector with encoded information, but by the light which we have here, we cannot really say that, because that could be like the lighting effect. And exactly pictures on which we can say about we can mention exactly such things, like there are some lighting issues. We cannot really predict if certain areas could contain those colors or couldn't contain that literally related to the environment where that picture was taken. Such pictures are most likely assumed to be a good data storage pictures, really. And the thing is that we have to literally pick one or two components of pixels. In most of the cases, it's only one, which you'll be using for storing a data. So since here we have orange colors, yellow colors, and the red tones, right? It means that, by the way, the yellow color is actually a combination of red and green colors. I mean components. So literally all of these colors we have on this picture says us that the red component is really unpredictable for a lot of these pixels we have on the picture, and at the same time there are a lot of varieties because of the tones of the picture. So it means we can literally write data replacing the red component of pixels. That makes sense, right?
Yeah.
And how do we say that we really can do that? Because there are varieties for the component from a 0 to 255. And what this thing corresponds to? There is such thing as ASCII table. I suppose pretty common thing, right? Like this one. So we can have characters, and every character has its own code, right? And especially for the for the codes that contain at least only English characters, I mean letters, right? Plus some technical characters and digits. Well, that would be fairly enough. Because in the basic ASCII table, well, here we have 128 variations, but that comes for the case when when character being done by seven bits. But we are using nowadays everywhere extended ASCII table, which was not the initial one, which takes literally 8 bits per symbol at least. So we can not a lot of oh, sorry. So we can not to think a lot of about this. We can just use English language, and we can make pure conversion from text to character codes, and we can write them into this component. To predict what kind of codes they would be, we can use a character map application, which is Windows default one. And we can literally find out that every symbol has a corresponding code. Here we have a hexadecimal codes, and literally by that we can predict if specific set of characters would contain corresponding codes. So 8 bits, it means 2 hexadecimal values. So if the pixel is covered by the code which takes only 2 rightmost codes from this one, which I kind of round by my cursor, right? Then that's fairly enough for our experiment. So that will fit into pixel component. So that's what it is. So what we'll be doing? We will be using a the pillow component, which is not installed by default. So how to install that? There is a Python repository which we can use. So we will need to use pip application. Pip application is the part of a Python installation. You can just use that to get the library. So we can run pip install pillow to get the library. Well, in my case, I already have it, right? Okay, the new release is available. Well, I can even upgrade. No, it's about the pip. Well, in this case, I'm not gonna upgrade that. If that would be a pillow library, I would upgrade that. In your case, you would be downloading that. And when you download that, we can use that because it will be saved into folder pil, and there will be a lot of files like image and image draw, which we will be using. So we will be opening a picture. we will be opening the picture pixels. We'll be getting size, horizontal and vertical size of them, so amount. Nextly, we'll be making we will be having a straight access to pixels. Next, we will be making the file in which we will save coordinates of pixels we modify. Then we would be taking from the user the text by the input. So it's like in C++ scanf or just scan. You know the C++, right?
Yeah.
Okay.
We had last year.
Yeah. So literally it's something similar like scan function. Okay. So what happens next? Next, as you can see, we have this complicated construction. So we go through every symbol of the text, and for each of them, we are returning back as the result of iteration of the for loop and ort of lm. Well, lm is a symbol, and ort function is implemented in a lot of programming languages, and it makes conversion a symbol to symbols code. And since we have square brackets around, we are pulling those codes into the array. That's what happens in this code fragment. And by this for loop, we use another lm definition that allows to go a symbol by symbol through this array we have in highlighted code. And then what we do, we make a tuple of two random values that somehow finds a random value for the vertical and horizontal position of the picture and saves that into variable key. And this variable, which has a tuple of x, y positions, it can be used as the position of the pixel from which is the least, so we can modify it, right? And we are taking values starting from index 1 till index 3 excluded that. So since we have three channels RGB, we're taking G and B channels. So we can write them into these two variables. Because, well, why we can write this? Because since here we are taking two elements, so we can assign each element to each variable. That's why this thing is possible. And then what we do, we put a pixel into position which was provided here. And what data do we give? We give a data in the list form, in the tuple form in this case, of previously red, green, and blue channels, and the red one will be replaced by our symbol code. And then we write into the file exact position of the symbol which we modified. And literally, since you see that there is offset for the code line of the for loop ends, right? And then we go to another code that literally finalizes things. So showing that things are saved, saving the image with modified pixels, and closing the textual file. And literally that makes it possible to encode the data into those pixels. Well, guys, I will show you how it works, and while I'm unzipping files, you can write in the chat some phrase you would like me to encode for well, as an example. So you can write some phrase I will take and put into example so you would see how it really works. Okay, so here we have a keys and new image, which is not really needed for us in this moment. And here we have a fancy picture of the cat. Well, cool picture. And here we have decrypt and encrypt files. Well, about encrypting the data, I already described you how it works. So I will just make in the terminal, open the terminal, and I will try to run this encrypt file using command Python encrypt. And I will check, I will check a chat. Maybe you place some text you would like to encode. Okay, you didn't. Okay, let it be so. Let's take this text and let's put it inside. Because you see, we are asked to have the text, so let's put it inside and let's save it. So things are fine, everything is saved. And you see we have this new image and we have keys.txt. So you see, we have all of these pixel positions mentioned there, right? And we have a new image saved in the PNG format. Again, there's the reason for that, so we wouldn't lose the original data which we write inside. And opening that picture, as you can see, we cannot really see if there is some pixel with modified red channel. It's just not possible to say something like that about such picture pixels. Yeah, so that's the thing. And okay, right now we would like to decrypt the file. So I can take that file name and we can run it. So surely we have to use the Python for this purpose. And you see, we get the message which we encoded previously. Surely that happens only because of these keys. Otherwise application wouldn't know where to search for such data, because actually from every pixel we can extract all of those 3 channels, and we can imagine that all of those could be codes of symbols, but it's not really so, as you understand. And right now,
So can I ask?
yeah.
So if you don't have that keys text, you won't be able to decrypt it?
Yes, it wouldn't be possible. Or there could be another thing, like if a priori, which means in advance, you would have a rule how to select these pixels, then we wouldn't have to have this keys.txt file.
Okay.
All right, let's maybe take a look how that decrypt works, and I can show you the next slides. So literally what we do? We have to have path to the image, but in the decrypt PI it was placed inside already. We are opening, we are accessing the pixels. Nextly, we are opening keys file, and literally we are going through each of the lines of the file. By firstly saving those lines in, as you can see, using for loop into the array. So y becomes the array. And literally what we do nextly we use the regex syntaxes to find out in the text what exactly. A starting bracket with number, as you can see, and where in the end of that number there is the comma. So literally a beginning component of the coordinate. And then when it's been found out, then we can say that afterwards there comes the second part of that text. So, and we find out such pairs of data, and we converting them to integers. Literally, by such conversion, we erase non-digit symbols. by such conversion by integer function. And that allows us to have the first part of the coordinate and the second part of the coordinate. And we append both of them, well, into the tuple, as you can see, because there is the round type brackets. So we have a tuple of x, y, and we put such tuples into the array named keys. And then what we do next, we just go through the keys. Every element is being represented by into iteration by variable key. And what we do, we just use that key as the coordinate for the pixel, and we take a 0 component, so the first component, the red component. And as you understand, guys, that red component is literally the code, right? And all of those red components have been placed into array A. And then we go through the array A. We convert every element to the character, assuming that every element is the code. Well, literally the number. So CHR makes a symbol from the code. So it's the opposite function of the OR. You can see we use square brackets, so the result is an array, and that array is being matched by the join to a text, which we have here. Literally, here we can even say that we are using a textual splitter of components, and array is being converted to the text by this. And in the end, we have the result. Well, that's the idea of such code. Does that make a sense?
I mean, yeah, it does, but
What
practice,
exactly?
practice, you know.
Yeah, practice, practice, and practice as well, for sure. Okay, so guys, I would like you to try to make something like the form I did. I will just show you that, right? And I will try, and I will ask you guys to try to make something like this one. I will even place this inside to run exactly this thing. Next, I go for the Python form, and here we have a form. So I am encoding the text into the picture, and I'm decoding. So please, guys, try to do something like this. Well, we have plenty of time, so I don't know, maybe 10 minutes could be enough, or maybe even more. Let's see. But again, you need to have a practice related to this. But anyways, on a Wednesday, so on the previous classes, at least there were some results, good results related to forms. The only thing it's a bit badly that we have only 2 students connected, so literally less than half of the group. So yeah.
Yeah, that's sad. I don't even know why, like, they're not coming. On the previous lessons today, we had, I think, 3. On the first lesson today, we had 4 people. I don't know, is it Friday or everybody's busy?
I don't know. I may assume that maybe they don't like me. Who knows? Who knows? But at least good for you. You can always ask, and there are almost no competitors who would say no. Please answer better my questions than his.
I mean, it's like individual lessons.
Yeah, exactly. Okay, so may I assume to have the result in like maybe 10 minutes so we could
No
analyze
chance.
that? Like,
No chance.
no chance. All right. All right. Then, yeah, go ahead.
Unless, I mean, we can do it together. Like you
Yes,
can do, and we both talk.
yeah. And maybe Rokas can join as well. Okay. Well, let's then create something like this, right? Okay. So, what do we have to start with? Well, I suppose we can open for the as the helping hand the the GUI presentation we used previous time. And what we will be using? We'll be using a Tinker, right? With the possibility to show some result, maybe as the message box, right? So we'll be making function that literally will maybe encode data or decode data, but that will be a reaction on pressing a button. That could be what could be implemented. So let's take this one as the template of our application. And we'll need to create the file. Let's just call it a form.py, like this. And let's open that in Notepad, and let's place the code inside, like this. And we will try to write code in a full row way. So we have this one. And moreover, we can have a lot of different parameters. In my this pre-prepared example, I used a lot of different formatting things. So you can see we can have a font, the size, the weight of the text. So we can create a kind of the font stylistics, and we can apply font stylistics for every visible element. And it's not only for the button, it's even for the checkboxes, since they have the textual part, radio boxes, lists, combo boxes, and so on and so on. All of these things is possible, and we can have a foreground and a background colorings. So FG, BG, all this will be usable. So let's maybe create a new font which we'll be using for our application, even besides the fact that application is pretty small. Let's use it. Let's use Helvetic. I don't know if you have this font, but it's really cool. Or maybe we can use Cursiva, or maybe we can use the, I don't know, Verdana. All of them are kind of cool ones. I will take the font like 16, and I will use maybe Verdana font, which has to be installed on every machine, I suppose. Okay, so we have the button itself, and first we will be having that button for encoding the text. Encode. That will be the text in the button. Next, we will be packing that, and we will try to place that maybe somewhere on the left position. So, I mean, of the window, or maybe, I don't know. Let it be just on the top. So no big differences. Let it be just on the top by default. But we will have to have the font. So we can go for the font, and we can use my font. Well, if we would like to just check if everything cool, yeah, so here we have the font, and that's it. Okay, in the same time, we would need to have the button for decoding, because firstly we have to make the interface and then everything the rest. Okay, looks great. Maybe we could even change the foreground as maybe green text. Well, because why not? Okay, how will it be looking like? Let's see if we didn't make any mistakes and if we are on the right way. Okay, maybe I didn't use the font library. Give me a second, please. Ah, yes, I didn't use the font. Yeah. Okay, let's add the library of the font, and then it will be possible to use it. So we have encode and decode. Okay, we have something here that's pretty cool. And now let's add a functionality to encode and decode buttons related to the working with a picture, right? So we will have to have two different functions. One will encode data, another will decode data. So let's call it FNCT, like the prefix which I use always for functions. Let's call it encode. Well, fairly that it will have the text box in the end, and there will be a decode. Okay, looks great, and we have to use these names as the comments. Again, without the arguments, we're using them, and we're using them to say which code will be run once the button will be affected. And the only way how it will be affected is, clicked actually. So what happens next? Next, let's take those codes we have into encrypt. Well, firstly, let's take the libraries. Let's place them here, and let's take the code itself. So here we will have it. And we'll place them before this. And since in this code I use the tabulation sign, I will continue using that in a such way. Okay, here we have an image which is predefined, and then we have the classical input of the text. But such thing, I suppose, wouldn't be working because we have to ask a user for the text to type. Otherwise, there would be nothing. So let's think about how we can ask a user to provide an information. In this case, since I don't have that example, I will just falsely take that from the internet. Python Kinter Python 3 Kinter input user. Okay, so that's looks like as the entry. Okay, so just in case, I will take a look at what they have in the entry.
How did you mark all the entries?
It works in the macOS in a such way.
Oh, okay.
macOS system provides a lot of things. If you like, I can show you an example. So I'm making a screenshot. You see, right? I'm saving that. And you can see I'm opening the screenshot right here. And see what I can do. I can take text.
I mean, that's pretty neat.
Yeah, well, there are a lot of functionalities, a lot of cool functionalities actually. Yeah, we were looking for the message box with the text input. Okay, maybe I can just write that with input. Okay, so that's okay. It will be ask string. Okay, I will take it. I will put this inside like this, and I will try to and use it. So for me, it will be the first operation. Like I will just firstly try if that works. Yeah, that works. So that's cool. Okay. In the terminal we are asked. Okay, that looks really cool. That looks really cool. Okay, so let's call it text to encode. Text. What you would like to encode. Okay, that will be our question. And text to encode will be used instead of this input. Okay. Well, about most of these codes, well, we already had a talk. I even wrote comments to all of this text, all of these codes, to make it clear what happens there. And in the end, we'll have a printout like all is done. But this is for the terminal. We will make it in the message box way. And picture will be saved, and file with keys will be closed. So I will write like a keys written to txt file, and let's say the title of the window will be just encode, and this print can be just hidden, commented, and that's it. Let's see how this will work. So I'm running the Python form again. I'm making the encoding. I would like to save ABCDEF. Okay. And keys are written to keys.txt file. So the process is done. Okay, looks great. And let's now implement a decode function. Right now there is just a hello world. Okay, looks great. What we can do? Well, again, let's copy most of that code from the decrypt PI file. Here we don't have much. Well, we will have to have the regex library. So let's take that one. Okay, let's not to mix imports and the regular code. I will just place a new line symbol between them. Okay. And now let's use a decrypt code. This one. Okay, looks really awesome. and let's place that before the message box. And again, since I use the multi-tabulation sign, I will keep using that. Okay, so we have a predefined name of the image we're going through. We have predefined name of the keys file we will be using, and that's it. So I suppose we would need to save the decoded text in a such way, and we could show a result in the manner of the variable for sure. And I suppose the title of such a window will be just a decode, and that's it. That will be fairly enough. Okay, looks great, looks really awesome, and let's see how that works. So let's run our code, and let's go for an encode A B C D E F, for example. Okay, looks great, and now let's decode that, and we got the result A B C D E F. So as you can see, it's not super complicated. And now I would like to ask you again if I can ask you to try to make it on your own, on your computers. Would you be ready to do that, guys? At least to try.
Well, I mean, we can try. I don't think
Definitely.
we have enough time, but
Fairly saying we have like a 20 minutes, right? If I'm not mistaken.
yeah, something like that.
Okay, so at least you can try. If you will fail, it's not a problem. We have a lot of time before the next classes, so you have a time to train yourself.
Okay.
All right, and while you are making that, I will be uploading that form file which I just created in the system.
Okay.
All right, so the file is inside, but please guys try things on your own. It's always better. All right, guys, so we have several minutes left, right? What is the progress? Maybe you already made one of those functionalities, for example, encoding.
No, I made the buttons to be green and red.
And is that it?
Yeah.
Okay, okay. All right. Since we will have the next classes somewhere in November, so I will place at least like a 3 or 4 homeworks for you. So you will need to make them before the next classes we will have.
Okay, but it's gonna be from what we learned, yes?
Um, well,
Or
for sure, the only you will need to structure algorithms. Well, for example, a Caesar cipher, right? Well, not really complicated stuff.
for you?
Um, at least I don't know about Lithuania, but in Latvia we do that at mid schools. Okay, for example, what is that Caesar cipher, right? Again, we can go to Wikipedia. So we have a text, right? A, B, C, D, right? And we are converting that. Well, we're changing each symbol's code. For example, where it was E, it becomes B. Where it was D, it becomes A. And by that, we encode the text.
I mean,
And
it
then,
sounds familiar, but I don't
yeah,
know if I've ever done it before.
yes, it even sounds very simple. So,
But is it simple to make a program? I don't
yes.
think so.
You know, I would probably do that maximum using 10 code lines.
Well, I don't know. I could use ChatGPT for that. No, I'm joking. I'm not using that.
The thing is that I don't know how it happens, but but somehow in almost in every course related to Utana Kalegi, I have students who are asking ChatGPT, well, how to solve tasks. Mm, well, maybe you shouldn't assume that that's the good practice. Because during studies actually you are pulling on the higher level your capacity and during thinking process you just make your own capacities broader and when you just ask, for example, ChatGPT or whatever, you're not evolving. That's the problem.
I mean, I understand. Yes.
For example, I'm not forcing not to do that, but you can try to take a look on the results in the math, for example, for students and just for maybe just mid school people when they have calculators and they don't have. That's basically is a good example because those who are using calculator always they're not capable to calculate. I would say it's a really pity example, but it's really example from observations of these cases.
I understand. I understand. I was joking about ChatGPT. I was doing with the examples from that number 4 GUI with the import thinker.
Mm-hmm. Yeah,
But that's as far as I got.
mm-hmm. Okay. Well. I couldn't not to tell this because as I said, somehow students in your institution they use that, and then when they don't have the access to the chat GPT, well, there are no results. Well, just no results, and that's very problematic. It's like internet. It's full of cool information, really useful information. But in the same time, there are a lot of rubbish information, I would say. Okay. So I suppose there are no questions about what we had today, right? Definitely you need to practice. I will open those tasks for you guys. Actually, the only few placed of you are still in the system. I will have to add the rest of them. So anyways, before the next classes, we have like I don't know, maybe we can call it like a 2 months, right? So anyways, you will have a time mm, uh, to make those solutions without any hurrying, without any stress, and like you wouldn't have a time. You will have 2 months for this.
I mean,
Okay.
yeah,
Yeah.
there will be enough time for
Yeah.
everything.
It will be fairly enough time. Yes, and you can always write me a message if you will have questions. Uh, if you will need some consultation, okay, we can make a consultation for the whole group if there will be necessity for that.
Okay, I will let them know.
Okay, good. All right. Well, if we are good so far, then I would like to say thank you for attending this class. I really appreciate that, and I'm really looking forward to see the whole group next time when we'll have next classes.
Let's hope so.
Yeah, exactly. All right, guys. So have a nice evening and see you next time. And definitely don't stress about those homeworks. You have a lot of time for doing them. Okay, guys. If you will have questions, don't be shy to write in the Moodle chat because not really frequently, but at least once a week, I will be opening that and looking if I have some messages. All right, guys.
Okay,
Bye bye.
have a nice evening.
You too.